In this video, I'm going to introduce the resources and homework associated with the Unit 2.4 Proofs material. This isn't an introduction to proofs, but to the learning resources and homework associated with that material. So right now I'm on the home page. One way to get to the learning materials is to scroll down to the bottom of the home page and go to this little bit where I've got links to all of the course materials. We are looking at proofs for week 6 and 7. If you click on this link, it brings you to the learning materials for the proofs material. As usual, there's a little guide with some suggestions. There's a schedule of what you should do and when. So hopefully during week 6, we're now in week 7, you started looking through some of the proofs material. And then here are these materials referred to above. So we've got some resources, including a study plan and some advice for learning the material, a handy handout with the rules and schematics, and a link to a complete YouTube playlist. Amongst other things, that playlist includes the introductory lecture videos. The first one just introduces the proof method, what exactly it is we're doing. And then the next two introduce the 5 basic inference rules that make up the proof method for us in a little bit more detail, more slowly. And then finally, there's lots of practice exercises with solutions. The number one thing you need to do to learn the proofs material is to practice at the level that is appropriate for you. So when you're just beginning, maybe you start off with some intro exercises. If you pick it up right away, feel free to skip all that and move to 3.7. This is the level we're trying to work towards, the level that will be on the final exam. One thing I definitely recommend doing is the drill, especially after you've watched the proof videos, just to really get the patterns we're looking for, to get clear on what those patterns are. This material is all about recognizing and using patterns of reasoning we know to be valid. So that's the materials for the proofs stuff. The next thing we'll navigate to is the homework. I received a few notes in weekly check-ins that there's so much stuff in the to-do list that it's confusing. I don't recommend navigating to things through the to-do list because everything is broken up into little pieces. And in part, that's so if you want to redo a homework, you don't have to redo all of it. You can just redo the little part that you want to redo. So navigate to the week we're on. We're at week 6 here. And proofs. So this is the page we were just at. Here's the homework for week 6. There will also be proofs for week 7. So I've got week 7 down here, and here's more homework associated with the proofs material. So let's look at week 6's proofs homework. Okay, so the beginning of the first proof homework is trying to connect this material to what we've been doing all semester, summer, with Unit 2, the logic portion of the course. So we're starting with an example argument using skills that we developed earlier: clarify, reconstruct in standard form. Let's translate it into symbolic notation. Here's our argument in symbolic notation, and I'm telling you, this is a valid argument. And what we're going to do now is prove it. We did develop this counterexample method for proving things are valid or invalid. So one way we could prove it is to try to come up with a counterexample, and if it seems like you can't, then it seems valid. This one you might be able to reason through in your head and convince yourself that if these 3 things are true, then this just has to be true. I just see it. But if you don't just see it, we have other methods to give a more clear and concrete proof that it is valid. We can use the truth table method to prove that it is valid. So I've constructed the truth table for you. Here are the premises, here's the conclusion. I already told you it's valid, but if you look at it, you'll see that it is. And what's the reason why? A valid argument is one such that the premises jointly imply the conclusion, which means if all the premises are true, then the conclusion must also be true. There's only one row where all the premises are true. That's this one. And on that row, the conclusion is also true. An alternative way to put that is, if the premises are true, the conclusion cannot be false. There's no case where the premises are true and the conclusion is false. There's no counterexample row. So I'm going to select, there's no counterexample row. It's valid. Okay, now the proof method, our goal is to show that the conclusion follows from the premises by applying rules, and I'm going to lay out 3 of our 5 rules here that apply to the argument we're looking at, by applying rules that embody valid inferences. So instead of laying out this whole complicated table, we will prove that if these 3 things are true, this must also be true in a series of 3 steps. Each one is a simple, very common, valid pattern of reasoning. So here are 3 patterns of reasoning we know to be valid and that are very common. The first one is disjunctive syllogism. Let's just start with the pattern. So these are Greek letters, and I'm using Greek letters to symbolize that this could be any statement whatsoever. It does not have to be an atomic statement. The simplest version of this would be where these are atomic statements. So a concrete instance would be, I have either a cat or a dog. I don't have a cat, therefore it follows I have a dog. So this embodies I have either blank or blank, not one, therefore the other. Now these, like I said, could be any statement. So this little phi could stand for I don't have a cat. So maybe it's either I don't have a cat or I don't have a dog. And then this would mean it's not the case that I don't have a cat. So it follows I don't have a dog. It's whatever these 2 things are. It's this thing or that thing, not this thing, so it follows that thing. To put that rule into English, which is the thing I recommend memorizing. Don't try to memorize the picture. The picture helps you to make sense of it, but don't try to memorize the picture. Memorize the rule. If you have a disjunction, and you also have the negation of one of the disjuncts, either one, the parts are called disjuncts, then you may put the other one on a new line. You may infer it, you may derive it, you may put it on a new line. And then you justify it by saying, I used this rule. And then here are 2 other rules, modus ponens and the conjunction rule. Modus ponens says if you have a conditional, and you also have or know to be true the antecedent of that conditional, then it follows that the consequent of that conditional. The rule says if you have a conditional on a line, and you also have the antecedent of that conditional on another line, then you may put the consequent, the second part of that conditional, on a new line. Last but not least, the conjunction rule. This one just says if you know 2 things are true, then you know the conjunction of those things are true. So if you know I have a cat and you know I have a dog, then you know that I have a cat and a dog. So each of these rules represents a valid argument form, a valid pattern of reasoning. And our goal is to prove that this original argument is valid by breaking it into a series of valid inferences or steps. So here it is modeled. Here's our argument. I've taken that conclusion, I've moved it up out of the way. Our goal is to show that this follows, that if these are true, this must also be true by going through a series of valid steps. Our first rule says if you know a disjunction is true, or if you have a disjunction on a line, and you also have the negation of one of the disjuncts on a line, and we do, the disjunction has 2 disjuncts. The first disjunct is this whole part, everything on the left-hand side. The other disjunct is everything on the right-hand side. This is the negation of this, so it follows that this. It's either this thing or it's this thing. It's not this thing, so it is that thing. So we can put P on a line, and then we justify doing that by citing the 2 lines we were looking at, lines 1 and 2, and the rule that we used, which is DS, or disjunctive syllogism. Now we have a new thing that we know to be true. If these are true, then this also has to be true. We proved it. So this is another piece that we have to work with. Now I have a conditional on a line, And I also have the antecedent of that conditional on its own line. So I can infer, derive, put on a new line the consequent of that conditional, and I'll justify doing it by citing the two lines I looked at, lines 3 and 4, and the rule that says I can do that. If you have conditional and you have the antecedent, you can put the consequent on a new line. Modus ponens. Finally, I'm ultimately trying to show that this conclusion follows from these premises. You know that whatever you're trying to get will be the last line of your proof, and we need to justify how we get to this. Well, I've shown that if these things are true, that P must be true, and if all these things are true, then B must be true. So if all this stuff is true, then P and B must be true. So if I know any two things on a line, I can put those two things into a conjunction. That's what the conjunction rule says. Any two statements on their own line, I can make a conjunction of those two statements on a new line. I justify doing that by citing the two lines I just put together, 4 and 5, and the rule I used to do it. Here are some formatting tips for completing proofs in Canvas because they are auto-graded. There are a couple of pretty straightforward things you need to follow, so be sure to put a comma between line numbers and put the line numbers in numerical order. It really doesn't matter logically, but this is what Canvas is going to look for. Don't spell out the names of the rules, just use their acronyms. Don't use unnecessary parentheses. Ideally, just copy and paste symbols if you want to use them, but you can use the ampersand for the dot, this instead of the horseshoe. Capitalization doesn't matter. Okay, so your first question is really just this one. You could copy and paste it, but ideally, try to reason through it on your own. The next set of questions is applying the rule to specific arguments. Do these concrete instances have the pattern of modus ponens? Does the rule apply to these? Is it being applied correctly or not? So modus ponens says, if you have a conditional on a line and you have the antecedent, the first part, of that conditional on another line, then you may put the consequent, the second part, of that conditional on a new line. So which of these have that pattern? We have a conditional, check, but we don't have the antecedent of that conditional. We have the consequent, and we've inferred, derived, put on a new line, the antecedent. This is an invalid pattern of reasoning. A concrete example would be, if you were born in the U.S., then you are a U.S. citizen. You are a U.S. citizen. Therefore, you were born in the U.S. It is possible that those two premises are true, and yet the conclusion is false. Perhaps you're a naturalized citizen. Both of these things would be true, and yet the conclusion would be false. So this is not a valid pattern of reasoning. It is not an example of modus ponens, which says you need the antecedent. Order matters. This is an example of modus ponens. We do have a conditional on line 1. Line 2 is the antecedent of that conditional, except we've removed parentheses because now they don't matter. The only function of them is to make it clear that these go together instead of having like A be the antecedent and these as a like the main operator is not the conjunction, it's the horseshoe. So this is the antecedent, and then we have inferred, put on a new line, the consequent, so this does have the pattern of modus ponens. Likewise, this has the pattern of modus ponens, and importantly, this does not. When the rule says you have a conditional on a line, it means that's the main operator. This is a disjunction that happens to have a conditional as a disjunct. So this is not an example of modus ponens. And you can go through and do that with disjunction, with modus tollens, and then complete some proofs on your own. Study advice. You're going to want to do more practice than what is in the homework. Use the resources in the proofs material. If you have already gotten started, you've tried the homework, or you've looked at the proofs material and you have questions about something specific, please feel free to follow up.